નમસ્કાર, હું આદર્શ છું. વેલકમ ટુ આદર્શ એજ્યુકેશન સોસાયટી. Hello students, today we will study about the irrational numbers. This is the topic of standard 9, chapter number 1, number systems. Right? In previous class, we have studied about the different type of number sets like natural numbers, whole numbers, integers and rational numbers. So, today's topic is irrational numbers. Right? So, the members in the irrational number sets are P upon Q form. That means the number which we can represent in the form of P by Q, that are called the rational numbers. So we know that the rational number contains the all the members of numbers previous number sets, like all the natural numbers, whole numbers and integers are the rational numbers. So is there any other numbers remain that are not included in the rational numbers? Yes, there are such numbers which we cannot put in the rational number set are called the irrational numbers, right? So the definition of irrational numbers are the numbers which we cannot be written in the form P by Q, where P and Q are integers and Q is not equal to 0, are called the irrational numbers. See this thing, cannot be written in the form P by Q. So rational numbers can be written in the form P by Q, but these irrational numbers cannot be written in the form of P upon Q. For examples, under root 2, under root 3, pi. These are the example of irrational numbers, right? Now you may think why pi is irrational number. We are taking the pi value is equals to 22 upon 7. Then it is the form of P by Q. Then why pi is the irrational number? It is because that we are not taking the actual value of pi. We are taking the approximate value of pi, and that is 22 upon 7 for our calculation to make it easy, right? But actually pi is a irrational number. So now there are two different sets. One is rational number set and second one is irrational number sets. Any member of irrationals is not irrational, and any number which are rational cannot be irrational. So these are two different sets of numbers. But what will happen if we put together all the numbers? So by taking all the numbers together, rational and irrational, the new number set is called the real numbers, right? So real numbers are represented as capital R, and what kind of member are there? -1, 0, 6, 11 upon 8, root 3. That means rational numbers and irrational numbers. Integers and natural number, all kind of number sets are included in the real number sets, right? So this is now a number line. Now we call it the real number line. Real number line means each point on this number line represent a unique real number. It may be rational or irrational, but it is real numbers, right? So now we know that how to represent the rational numbers on the number line, that you have studied already in standard 8. So how to represent irrational number on the number line? So this is the next topic. Locate under root 2 on number line. So to represent under root 2 on the number line, first of all we will draw a right angle triangle. To draw this diagram, we will first draw a line segment AB. Then at point B, we will take a 90-degree angle, and again we will take here BC, that is 1 unit, right? So what is the 1 unit means? You can take AB as 1 centimeter and BC as 1 centimeter. You can also take AB as 1 inch. Then you have to take BC also 1 inch, right? So this is our 1 unit. This is our 1 unit. Now join AC. So this is our right angle triangle ABC, in which AB is equals to BC and both are 1 unit. As this is a right angle triangle, we can use the Pythagoras rule to find out the value of this hypotenuse side. Right? The side that is opposite to the right angle is called the hypotenuse side. And this side AC, now we can write down AC square is equals to AB square plus BC square. AB is 1, BC is 1. So 1 square plus 1 square. 1 square is 1 and here also 1. This gives us 2. This is AC square is equals to 2. Now by taking the square root both the side, we will get here AC and right hand side we will get under root 2. That means this AC is now under root 2. The distance of point A to point C is under root 2. So now we will take this triangle on the number line. See here. Suppose this is our 0 and this is B point. Suppose this is one distance, so B is our 1. Right? So now AC is our root 2, but this is here. We have to take it on the number line. So we will draw an arc to take AC distance on the number line. So for doing that, you have to take an compass. Right? Point take on A to C distance, and from here you can now make an arc that touches this number line, right? So here you could get another point. So this point is suppose your P point, right? This is suppose P point. So now your AC and AP are equal because these are the radius of the circle. So your AP is equal to AC is equals to root 2. So in this way we can represent the root 2 on the number line. So if this is your 0, this B up to B it is 1 and this is O to P is root 2. Here we can write down as root 2. Right? OP is root 2. In the same way, now we will see how to represent root 3 on the number line. See, locate root 3 on the number line. So to locate this root 3 on the number line, again this diagram is as it is. We have studied in the previous line. This triangle remains as it is. Now what you have to do is, as we have taken here 90 degree, in the same way from this point you have to take a 90 degree angle and draw another line segment CD. That is also the same unit of 1. If this is, you have taken 1 inch, right? BC is also 1 inch and CD you have to take is 1 inch. Now join this point D to A, right? And this DA will become your root 3. How? See here. Here ACD is again a right angle triangle. See here. ACD is again a right angle triangle. So we can use the Pythagoras rule. So in triangle ACD, AD is hypotenuse. AD square is equals to AC square plus BC square. Now what is AC? AC is root 2. So root 2 square plus BC is 1 unit. So this will become root 2 square is 2 and this is our 1. So AD square is equals to 3. Right? By taking the square root both the side, here we will get AD and here we will get under root 3. That means AD is our root 3. So to take on the number line, we will draw this diagram on the number line. Right? Suppose this is your 0. This B is now 1. So this root 3 to take on the number line, again we will use the compass, point it on the 0, take a distance OD and make an arc like this and give it the point P. So now OD and OP are equal, right? You can AD and AP are equal, and that is root 3. So this distance, this is A to P, is root 3, right? In this way we can represent the root 3 on the number line, right? You can directly draw this diagram. You do not need to draw this diagram, because to understand this I have drawn it separately. Now in the same way, you can think now, if we move further and take 90 degree here, then what we will get? Under root 4. If we further move ahead, then what we will get? Under root 5. So in this way, we can represent any number on the number line. And this method is called the spiral method. There is another method to locate under root 5 on the number line. So to do that, see here. Take a triangle ABC, right angle triangle. AB is, now we have to take two units. See here, this is one unit, this is another unit, and from point B we have to take a 90 degree angle. But now this BC we have to take is only 1 centimeter or 1 inch, as you have taken it as 1 inch and 1 inch, total is 2 inch, then this you have to take as 1 inch only, right? So again, this is a right angle triangle ABC, so AC is the hypotenuse. Now according to the Pythagoras rule, AC square is equals to AB square plus BC square. AB is now 2, so AB is equals to 2 square, plus BC is 1 unit, so it is 1 square. So this is 4 plus 1, and the result is 5. AC square is equals to 5. Taking the square root both the side, we will get AC is equals to under root 5. This means A to C, this is our under root 5. So to represent this on the number line, again we will use this compass, right? Point it on 0 or A up to C and draw an arc, this. Draw an arc up to this point. And this point is, suppose this is a point P, then AP distance is represent the under root 5 on the number line. See, this is our 0, this is 1, this is 2, and after 2 we will get the under root 5, right? So this is AP is equals to AC is equals to root 5. So in this way also we can represent the under root 5 on the number line. Okay. So this is all about this lecture. Okay. Thank you. Thank you for joining us.